Hello, and welcome to this short explainer on recommender systems models. The goal of recommender systems is to match users with products. In order to do this, we employ various deep learning models. In this video, we'll explore the model architecture and data interactions on a very high level. Our users and products are stored in multiple tables, and we need to extract the relevant data, making it available to the model for training and inference. Before the model can train, the data needs to be converted to numeric scalar or vector format. After all, the model on the lowest level is just a bunch of matrices we add and multiply. Some features need to be pre-computed, for example, amount spent over a certain period of time. All of these go into the feature store. Let's follow one user's journey towards their recommendations. Our model consists of three layers: embedding projection layer, interaction, and prediction. The data flows through them in this order. First, the data from the feature store is fed into the embedding and projection layer. This is the layer that interfaces with the data in the form of individual features and converts them to vectors, which is the only format our models understand. Discrete data, such as store ID, product name, user ID, can be looked up in a table, where the resulting vector is the row, the number of which corresponds to the feature value. We call such a table an embedding table. If the feature is already a vector or some continuous scalars combined into a vector, we apply projection. This could be a multi-layer perceptron, or MLP, just series of matrix multiplications, which produces a vector of the dimension we require. These operations need to be done separately for each individual feature for both users and items, meaning the model requires a lot of memory to store all the tables and matrices. After all the embeddings and projections are done, we can concatenate these separate vectors into user and items representations, ready to travel further up the model layers. Once we have converted features to vectors, we can move to the interaction layer. Here the real learning happens as the user and item representations can interact with each other in many different ways. In essence, this is the core of our model. There are many ways to implement these interactions, not all of them involve deep learning. This is where we can get creative. After user and item vectors are done interacting, the result can proceed to the final layer, the prediction layer. Perhaps a multi-layer perceptron or some shallow neural net with a sigmoid or similar on top outputs a vector that means something for the given user. A number, usually in the 0 to 1 range, for each of the output vector cells may be interpreted as probability of a match with a particular item, or, better yet, as a rank of this particular user-item interaction. A threshold can help filter away the more unlikely interactions. At the end, this gives us our recommendations. This concludes the journey of the data through the recommendation system model. Thanks for watching.